Welcome to another tutorial of the Thermal System Design class. In this tutorial, we're going to start covering what meshing is. So for our example, we're just going to take a simple rectangle. As we can see, it's just a surface body. As we learned that from a sketch, we create a concept and we go to surfaces from sketch. It's a simple surface body with a 15-inch diameter, 15-inch length and 2-inch in height. So, but first of all, what is the meshing and why is it important? So, the way that ANSYS works is that it's like any type of finite element analysis software. It takes small elements from complicated geometries and it solves numerically step by step. So what it does is that it takes your geometry or your CAD file, whatever you're trying to simulate, and it separates it in small elements, as we can see here on this picture. It separates it in these square elements, or it can be different shapes, and it has multiple knots that helps the numerical models to solve for each of them. So that's the way that ANSYS works in very roughly. But that's how the meshing works. So there's different types of meshing. So first of all, we have the connectivity based meshing. We have structure, hybrid, and unstructured. We also have element based, whether we're working with a 2D model or a 3D model. For 2D, we have quadratic and triangular meshing. And for 3D, we have hexahedral and tetrahedral. So some examples of these geometries, for example, here we can see a structure mesh for 2D and 3D. We can see here that the 2D is just a simple structure, multiple squares, and here we can see on the 3D is something very similar. If we go to unstructured, we can see here simulating a blade for either a jet or a turbine. So we can see that it's unstructured along the blade, and that is to capture the fluency that we want alongside the blade. So sometimes we don't need that much on the edges of the domain in this case. So this square would be the domain. So we can see that the domain here at the edges is a little more coarser, and the more that we approach the blade, they're a little more fine. This is an unstructured meshing. We also have a hybrid meshing. So sometimes we can see here at the middle we have a very structured, very consistent mesh, and after that we have a more unstructured one. So this would work on cases where we were trying to simulate or study specific. We have areas of interest. For example, if we know that there's going to be a stress concentration at some fillet, or we know that because we drill a hole on one of the systems that we're going to have stress concentrations there. So there's different types of reasons why we do this hybrid one, and we don't care as much on the edges as well. And we also have the element base. So here on the left we have a simple quadratic meshing and a triangular meshing. It's very self-explanatory. We have squares on the quadratic and we have triangles on this one. And in a very similar concept, we have hexahedrons and tetrahedrons on the right hand side. So those are the different types of meshing. Depending on your problem and depending on the type of simulation that you're trying to make, it's gonna vary which type of meshing that we're gonna be making. So let's jump into an example. So we have here the geometry that we want to work with. Let's close this. So our geometry is set up. Notice here on the properties of the schematic of the geometry, on analysis type it says to 3D, we don't want to make a 3D analysis, this doesn't matter right now. We're not gonna make the complete analysis today, but just something to keep in mind that whenever you're making a 2D simulation, we'll go to 2D, and then we'll go to meshing because I changed my type of analysis. It's gonna ask me if I want to read the upstream data. Yes, I want to read it. So here we are with our geometry that is being imported from our design modeler. Let's change the view on this. So we see here our geometry of simple square, and let's run through some of the features that we have here on the meshing. So we have a simple generation tool just to generate the mesh whenever we need it. As we can see here, it's already asking us for a mesh generation. Name selection, basically this would help us, especially when we're doing unstructured meshing. I don't know, maybe this edge on the left, we want to select it, and we want a more finer mesh in this side than on this side. So maybe we select this one and we use a different method from the right side, or there's different reasons why we can use this name selection. We also have our models. See, we have a cross section, the mesh editing, mesh numbering, our display, how we want our geometry to be displayed. But the most important thing that we're gonna find here in the meshing, if we right click here on mesh, it's gonna give us multiple options. So if we go to insert, it's gonna give us methods. I'm just gonna click on methods. So it's gonna ask us to select the geometry, and here it's gonna ask us if we want a linear or quadratic element order. If we select the geometry, it's gonna give us more options. So it's something very important to keep in mind. We'll cover that on future tutorials. So we have the method, we have sizing, we have the refinement of the mesh, we have phase meshing, match control. We have multiple features to control our meshing that is going to be very important. It's going to be crucial for you to learn depending on the problem that you engineer are going to face. So yeah, same thing. It's going to ask us to update our mesh or generate the mesh. We also have a clear generated data. Whatever, if you don't like your mesh, we can start always from the beginning. So those are some of the features. So right now I was messing with it. So here the element size, like the default size, it was something like 0.71 inches. So it's gonna give us the default controls. So solver preference, if we click here, it's gonna ask us if we're working on Fluent, CFX, Polyflow. We're working on Fluent right now, so we'll leave it as that. The element order is gonna ask us to have it in a linear way or a quadratic. Here we also have sizing. We used to have a feature on ANSYS, we don't have it anymore, where you could by default select a more coarser or a medium or a finer meshing. So some of those features have disappeared, and you're not going to be using this side of sizing as much. So if for whatever reason you need more of the sizing, we go to insert and sizing, and it's going to give us more options on the type of meshing that we want. So here we have our quality. It's very important. Our targeted skewness, that's going to tell us how good our meshing is. Inflation, pass controls, and very important, nodes and elements. So right now you have a student version of ANSYS, so you have a limited number of elements that you can produce. So the more elements that we have, as we show here in the very beginning when we're explaining the mesh, so the smaller these elements are, the more accurate solution we're gonna get. That sometimes it's very tempting to say, oh well, then I'll just use as much elements as I can. But sometimes we can reduce the number of elements. We don't need to be as precise in some situations. For example, right here, we have a very simple square, so we're not gonna need a very detailed meshing in order for us to get a good solution. But in some cases, we're gonna need some finer meshing on some areas and coarser meshing on other areas. So all of those decisions is gonna impact your number of nodes and your number of elements. So please be advised to always take a look into this and see if you're actually on the right number of elements on the right sizing that you need. So here on default, it's gonna give us the element size that we want. So if this number is very small, the element size, guess what? Your elements are gonna pass the limit of your student version, and you're not gonna be able to produce any results. So let's generate this mesh on the default. So by default, this is the type of meshing that we will be getting. So we can see just multiple rectangles. Let's change this. For example, if we want a more quadratic form, let's generate it. We can see that we have a very similar trend, right? Let's generate it again. So if we want to make our elements a little bit smaller, so let's say for example we want 0.5, we'll be getting this. Also be advised and notice that the smaller the element is, the more computing time it needs for you to run a simulation. So let's reduce this number to 0.1. Hopefully we don't surpass our element sizing. So as you can tell, it took a little bit longer for us to generate this meshing, but we have very small element numbers. So we'll see later on that sometimes the accuracy of from one element to another element is going to be almost not noticeable depending on the geometry that we have. So sometimes we want to simplify some problems and simplifying our computing time by reducing the number of elements. But for now, this is going to be all in this tutorial.